plasticizer PVC. From the title, we understood that the presence of a plasticizers. So the presence of a plasticizers is nothing but a this-butyl phthalate. Okay, ma? Because of this plasticizer, the plastic should be molding is possible, and it can be molded into desired shape by applying suitable temperature and pressure in the presence of catalyst. Okay, ma? So because of the that flexibility in the molding purpose, it is mainly used for the raincoats, tablecloths, handbags, curtains, and electrical insulators, radio TV components, and all PVC shoes for beachwear. Okay, ma? So this is about the properties and applications of the polyvinyl chloride. Okay, ma? Now next polymer is the Teflon. Okay, ma? Teflon. Okay, ma? So anybody know what is the alternative name for Teflon, amma?
Fluon.
Fluon. Okay, ma. And the IUPAC name is the polytetrafluoroethylene. Polytetrafluoroethylene. So in polytetrafluoroethylene, what is the monomer, amma? What is the monomer?
Tetrafluoroethylene.
Tetrafluoroethylene. Okay, ma. So first of all, we learn what is the difference between the tetrafluoroethylene and ethylene. So in ethylene, the formula is CH2 double bond CH2 C2H4. So that four hydrogens are replaced by the four fluorine atoms. Most negative element of the entire periodic table. So that is the fluorine. So that fluorine atom is replaced by the surrounding hydrogens in the ethylene molecule. So actually, as per the formula of the ethylene, CH2 double bond CH2. So the surrounding four hydrogens are replaced by the four fluorine atoms. So that is called tetrafluoroethylene. So this tetrafluoroethylene undergoes the water emulsion polymerization. In the presence of a peroxide is used as a catalyst to give a polytetrafluoroethylene. And we see where n moles of the tetrafluoroethylene undergoes water emulsion polymerization. In the presence of a peroxide catalyst, it give polytetrafluoroethylene, where small n represents the n means what, amma? N means what?
Degree of monomer.
Degree of polymerization, where degree of polymerization represents the total number of the monomers which are participated in the reaction, or the number of the repeating units which are participated in the reaction. Okay, in the present polymerization, what is monomer, amma? In the present polymerization, what is the monomer?
Tetrafluoroethylene.
Tetrafluoroethylene. అమ్మా స్లైడ్ కనబడుతుందమ్మా మీకు టెఫ్లాన్ ప్రిపరేషన్ స్లైడ్
No, sir.
కనబడట్లేదు అమ్మా ఇప్పుడు అమ్మా అలాఫీ
Visible, sir.
విజిబుల్ ఓకే అమ్మా సో Teflon is nothing but a polytetrafluoroethylene. In polytetrafluoroethylene the monomer is the tetrafluoroethylene. So tetrafluoroethylene means it is looks like a molecule of the ethylene. Actually the formula for the ethylene is CH2 double bond CH2 C2H4. So that means it is surrounded by 4 hydrogen atoms. That 4 hydrogen atoms are replaced by the 4 fluorine atoms. 4 hydrogen atoms are replaced by the 4 fluorine atoms. Okay, ma? So this tetrafluoroethylene undergoes water emulsion polymerization in the presence of a benzyl peroxide acts as a catalyst to give a polytetrafluoroethylene. Where n moles of the tetrafluoroethylene undergoes water emulsion polymerization to give a polytetrafluoroethylene. In the presence of a benzyl peroxide acts as a catalyst. Okay, ma? So this is about the preparation for Teflon. And the properties, Teflon is also called as a fluon. Okay, ma? So due to the presence of highly electronegative fluorine atoms, already in the structure previous slide we observe the 4 fluorine atoms are surrounded by the carbon. So this is highly electronegative atoms. So because of that highly electronegative atoms, there are strong attractive force. Strong attractive force is responsible for the high toughness and high chemical resistance towards almost all the chemicals. But except the conditions is not satisfied in case of hot alkali metal like sodium metal and also hot fluorine. Okay, ma? So this is about the properties of a Teflon. And next we see uses. Uses means it is most probably used in the kitchenware and domestic purpose, especially in the pressure cookers. For the pressure cooker, the gasket is very important because it provides the leakage of the vapor pressure from the pressure cooker. Okay, ma? So such material is made with Teflon. So it is mainly making seals and gaskets which have to withstand very high temperature. You know about pressure cooker, that means boiling of a rice. So for the pressure we maintain the nearly 100 degrees temperature. The temperature should be very high. At the temperature the material should be withstand at very high temperature. So for the purpose that material is made with especially gaskets with Teflon material. And also it is also used for the insulation of electrical items and for making non-sticky surface coating, particularly for the cooking utensils. Okay, ma? And the third one, Teflon is used as a insulating material for motors, transformers, cables, wires, fitting, etc. So this Teflon is not only used for domestic kitchen purpose and also used for the industrial purpose. Okay, ma? So this is about the properties and uses of a Teflon. Okay, ma? Now coming to the topic, what is the polymerization takes place in Teflon, amma? Amma, what is the polymerization takes place in Teflon?
Addition polymerization.
No. See this slide, amma. Alafi visible this slide. Water emulsion polymerization. And further addition is divided into different types. In this case, is definitely specifically we mention water emulsion polymerization in the presence of a benzyl peroxide acts as a catalyst. Okay, amma. And what is the monomer, amma? What is the monomer in Teflon?
Tetrafluoroethylene.
Okay, tetrafluoroethylene undergoes polymerization to give polytetrafluoroethylene. Okay, what is the alternative name for Teflon, amma?
Fluon.
Okay, why Teflon exhibits strong attractive forces? Why Teflon exhibits strong attractive forces? because presence of a highly electronegative fluorine atoms. Okay, see the structure in previous slide. It is surrounded by 4 fluorine atoms. So because of this 4 fluorine atoms, it is strongly attractive forces. Okay, and that forces are responsible for the high toughness and high chemical resistance. Almost all the chemicals except hot alkali and hot fluorine. Okay, now tell me, what are the uses of Teflon, amma? What are the uses of Teflon? It is mainly used for the both domestic and industrial purpose. Okay, in domestic purpose, used for the pressure cookers, especially especially making for gaskets, and also for the installation of electrical items and making non-sticky surface coating, used for the cooking utensils. And also for industry purpose, it is also insulating material for motors, transformers, cables, wires, and fitting, etc. Okay, all of you understood polyvinyl chloride and Teflon, amma? Preparation, properties, and applications. Give me response. All of you understood these two polymers, PVC and Teflon?
Yes, sir.
Okay. Next, I shared the remaining polymers, Backlight and nylon 66. Okay, all of you visible my screen, amma? Backlight and nylon 66. All of you visual my screen, Backlight and nylon 66.
Yes, sir.
Okay. Yes, sir.
Okay, first of all, this Backlight and nylon 66 comes under category of addition polymers or condensation polymers.
Addition polymers.
Condensation polymers.
Condensation polymers are the right answer. Previously, PVC and Teflon comes under category of addition polymers. Now the present polymers, Backlight and nylon 66 comes under category of condensation polymers. Okay, tell me one more answer. Out of two polymers, addition polymers or condensation, which are more stable?
Condensation.
Condensation polymers are more stable. Do you know the reason? Because condensation polymers contains the cross-linking chain. Okay, very good. So topic also covers the both preparation, properties, and applications. Now let us start the preparation of Backlight. So first of all, Backlight. So Backlight is the commercial name for the polymer obtained by the polymerization of phenol and formaldehyde. Okay, so first of all, Backlight is the commercial name, but based on reactants, these polymer is named as the phenol formaldehyde resins. So the reactant phenol and reacts with the B reactant formaldehyde. If these reactants reacts with the 1:1 ratio, to get a monomethylol phenol. That means the substance is only one, that is only one methylol. If the reactants, that means phenol and formaldehyde, reacts with the 1:2 ratio to give the dimethylol phenol. So that means on the ring there is a two substance, and if the reactants reacts with the phenol and formaldehyde within 1:3 ratio to give a trimethylol phenol. All of you visible the preparation slide, amma?
No, sir.
No, sir.
Now it is visible, amma?
Yes, sir.
Okay, amma. So this is the preparation for the backlight, amma. First of all, the backlight is the commercial name for the polymer, which is obtained by the polymerization of phenol and formaldehyde. So because of the involvement of the phenol and formaldehyde, these resins are called as a phenol formaldehyde resins. Okay, amma. So first of all, what is the formula for phenol, amma? Anybody know? What is the formula for phenol?
C6H6O.
C6H6O. Okay.
OH.
C6H5OH. Okay, ma? Actually, the benzene formula C6H6. One hydrogen is replaced by the OH. So the formula becomes C6H5OH. So see the structure. Without OH group, it is a benzene ring. Because of the formula, one OH is substituted on the top of the ring. So the formula becomes C6H5OH. So this is the structure for phenol. And it reacts with the formaldehyde. Formaldehyde means actually the functional group of the aldehyde is CHO and it linked with the H, so that is called formaldehyde. Okay, ma? Now phenol and formaldehyde reacts with the 1:1 ratio. 1:1 ratio, they give the monomethylol phenol. Monomethylol phenol. And further, that phenol reacts with the formaldehyde with 1:2 ratio. 1:2 ratio, that gives the dimethylol phenol. Dimethylol phenol. And if this phenol and formaldehyde reacts with the 1:3 ratio, 1:3 ratio, that gives the trimethylol phenol. Trimethylol phenol. Okay, ma? So because of the reactant ratio, the products are finalized. If these reactants, both phenol and formaldehyde, reacts with 1:1 to give a monomethylol. If these reactants reacts with 1:2 ratio, that is called dimethylol phenol. If these reactants are reacts with the 1:3 ratio, that is called trimethyl Okay, ma. Emma, all of you audible to me? Emma, am I audible to you?
Yes, sir.
Okay, ma. So this is the second step of the preparation of backlight, amma. So in the previous slide, we considered the monomethylophenol. That monomethylophenol reacts with the other monomethylophenol, and with the elimination of the water molecule to give a nova-like region. See, nova-like region having the horizontal linkage, and this nova-like region is reacts with the formaldehyde and to give a hexamethylene diamine. So that is a cross-linked product. So see the final step. This is a cross-linked product. It is having both horizontal link and vertical link. Both horizontal link and vertical link. Okay, ma? So because of this cross-linking, the resultant product is the more stable. Okay, ma? So totally this backlight involves the 3 steps preparation. The first step is the phenol and formaldehyde reacts with each other with different ratios. For 1:1, it gives monomethylol. For 1:2, dimethylol. For 1:3, trimethylol. And in the second step, monomethylphenol reacts with the other monomethylphenol by the elimination of the water molecule to give a nova-like region. But this nova-like region having the only horizontal link, it is less stable. So for the purpose of to get the stability, further it is heated in the presence of formaldehyde to give a curing agent that is nothing but cross-linked polymer that is called hexamethylene diamine, and the commercial name is Backelite. So see the final structure, it is having both horizontal link and vertical link. So due to this cross-linking, the product is highly stable. Okay, ma? So tomorrow we'll discuss about the properties and applications of a backlight. Okay, amma? All of you understood the preparation for the backlight, amma? Amma, all of you understood the preparation of backlight?
Yes, sir.
Okay, amma. Thank you. Thank you for listening.